Okay, we are into section 2.3, day 2, and it's called real zeros, in other words, no imaginaries, of polynomial functions. So, with that being said, I'm going to introduce you to this crazy little theorem called the rational zeros theorem. All it is plus or minus p over plus or minus q. And I'm going to use this little trinomial thing to help you understand what this is for, okay? So, if I was on a test or some whatever, homework assignment or quiz, I would look at this. There's no way I would use this. I would say, wait a minute, I think we can factor that. And I'd go x and x. And what are two factors of negative 48 that add up to negative 13? A little bit of a challenge, but negative 16 and 3. So minus 16 and 3. So my answers, my zeros, would be 16 or negative 3. So keep that in mind. Now, you might be saying, well, why are you showing us this? I'm looking at my packet here, and I see example 3 and 4. In example 3, highest power is a cubic. In example 4, the highest power is also a cubic. Because the rule of this rational root theorem is extremely beneficial for those cubics. So I'm using this one to help you understand what in the world it does. Okay? So with that being said, P are all of the real factors of your constant. So that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and I picked this one on purpose, plus or minus 16, because it's just got a bazillion of them, and then plus or minus 24, and then plus or minus 48. That is a lot of possible factors of our constant. Now, the good news is this is a 1. Now, I will say this, watch carefully. The plus or minus in the bottom, you don't need a double plus or minus in the top, plus or minus in the bottom. As long as you know it's plus or minus in the top, your brain will process the fact that it can be plus or minus. You don't need a plus or minus in the top and plus or minus in the bottom, okay? But the Q are all the factors of your leading coefficient. So in this case, it would be 1. Now, that makes it very easy. So what in the world is this list? That list is the list of all possible rational root. Root means zeros. It also means solution of this equation. So, question, see our answers right here, 16 or negative 3? Here it is. There's 16, and there's negative 3. So do those two exist in our big old list? Yes, they do. Now you may be saying, well, that seems like a big old waste of time. I agree with you, if it's one of these that are factorable. But now we're going to get into these cubics, and you're going to see the benefit of P over Q. I promise.